Hello everyone and welcome back to another video. Today we'll be covering discrete random variables. Now discrete random variables are variables that may only take on a finite number of possible values. So a variable that can take on values like 1, 2, 3, 4 may be a discrete random variable. Now let's say I define this variable as x and I assign each value a certain probability. This could be something like a dice roll, where let's say I have 6 numbers, 1, 2, 3, 4, 5, and 6, and each probability is 1 over 6 for each number. Now one fact about this is that the total probability is always equals to 1. So the sum of all the probabilities that a variable is going to get a certain value, summing up all these probabilities will get you equals to 1. Now let's try our question. Given the following probability density function, for a discrete random variable, a probability density function will be when you have some value of x and then you assign a probability to each of these values of x. So here the probability that I'll get a 1 will just be c. The probability that I'll get a 2 will be 4c, and so on and so forth. Now part A asks us to find c, and we can use the total probability to help us. So I have the sum of all these probabilities over here will be equals to 1. This means that c will be 1 over 55. Now for part B, we want to find the probability that x is between 2 and 4, inclusive of 2. So if we look at this, what values of x fulfills this? If we look at this, 2 definitely is in, 3 is in, but 4 is not. Because over here, we see that this is strictly less than 4. So we can write this as px equals to 2 plus px equals to 3, which is just 4c plus 9c, which is 13 over 55. Now the next few formula we're going to look at are all in your formula booklet. This is about expected value, variance, and linear transformation of variables. Let's start off with expected value. Now the expected value is somewhat similar to your mean. Your expected value ex will be the sum of all x times their probability for all x. So if we were to find ex for this question up here, this will be 1 times c plus 2 times 4c. We are taking the sum of all the x's times the px equals to x. And then we have plus 3 times 9c plus 4 times 16c plus 5 times 25c. And that's your expected value. Now the next thing, the expected value of gx, where g is just a random function, is just the sum of gx times the probability that x equals to x. The probability that we're using actually still stays the same. So if we wanted to find something like ex squared, this would just be the sum of all gx, which is x squared, times px equals to x. So we have x squared, which is everything square. So this is 1 square times c plus 2 square times 4c, and then we have plus all the way until 5 square times 25c. And that's what e of x squared will look like. Now the variance, which I write as VARx, is actually found with the expected value. The variance is just ex squared minus ex whole thing square. So remember the expected value of x squared that I was finding earlier, and then we are minusing this expected value squared. Now I'm going to show you how to find the expected value and the variance of discrete random variables in your GDC. The steps for finding the expected value and variance for discrete random variables in the GDC is very similar to that of descriptive stats. We'll first key in the x values into the first column, so 1, 2, 3, 4, and 5, and then my probabilities corresponding to each x value in the second column. So we have 1 over 55, 4 over 55, 9 over 55, 16 over 55, and finally 25 over 55. Now let's highlight these two columns, so we click the up arrow until it reaches the top and selects the whole column in blue. Then press shift and right arrow to select the second column as well. After we're done with these steps, we come over to the menu, statistics, stat calculations, and again we are still using one variable statistics. Click OK. And OK again. Now two important things. X bar will be your expected value. So your expected value is approximately 4.09. And sigma x will be your standard deviation. If we want to find the variance, it's just as simple as taking the square of this value. Now finally, we have the linear transformation of variables. So what does this mean? Let's say I have the expected value of some ax plus minus b. This will be actually equivalent to a ex plus minus b. So let's say we apply this formula. Let's say I want to find e 2x minus 3. This is the same as 2ex minus 3 as per this formula. Now the last thing is that the variance of ax plus minus b is actually a squared times variance x. So let's say I have something like the variance of 2x minus 3. This just equals to 2 squared, which is 4, times your variance. That's all for discrete random variables. Thank you so much for watching.